All right, so we have gone over distributed property just the other day, right? However, like I said, we talked about what's called the rainbow method, all right? And kind of an informal name for the method I taught you guys. The method we're going to talk about today is something called the area model method, okay? So you're going to see a different way of doing it, all right? But the reason why I want to show you this is because, as Common Core expects, it's just a method that's going to pop up on tests. It's going to pop up even on like the state test. And when you see it, sometimes it doesn't even look like it's asking you to use distributed property. It's just assumed that you'll use distributed property to solve it. So I want to make sure we go over it where you kind of can identify what it looks like and know what it's expecting, okay? So distributed property using the area model method, all right? So what I'd like you to do is to go ahead and it's labeled on your homework as the DP worksheet, which is just the distributed property worksheet. So go ahead and grab that worksheet right there. Okay, it just says distributed property of multiplication practice. And I think all of you guys have your name on it hopefully already. Okay, so what we're going to do is let's go ahead and let's take a look at problem number 3. Problem number 3. Now before we do this, I want to talk about a couple of things. The first thing is let's take a look. The little F was punched out here, but let's look at the directions and let's go ahead and close read them. All right, here we go. Fill in the
missing
information for each dimension and
area
as a sum or difference. I don't know why that colon's there, but it shouldn't be. All right, now fill in the missing information for each dimension an area as a sum or difference, okay? It sounds a little weird. Well, here's what they're talking about, okay? I'm going to take you guys back to elementary school, all right? And I want to talk just a brief talk about the lesson you had in elementary school when you were trying to find the area of a rectangle. Now, a lot of us don't like geometry, but this was one geometry lesson I think that a lot of people found pretty easy. So let's say, for example, this little rectangle had the width of 2 and the length of 4. So if we needed to find out the area, which is the space inside, okay, don't give me the answer, but who can tell me how would I go about finding the area of that rectangle? Nobody remembers how to find the area of a rectangle? You multiply what? The 4 and the 2. Okay? Ultimately, guys, what you do is you multiply the length with the width. All right? Length times width is how you find the area of a rectangle. Now, this is no different. Now, before we go on, I want to show you this no longer obviously is elementary school. You no longer have a nice little rectangle like this to find the area of. What they're saying is if you're going to find the area, what is the area not of 2 with the length of 4? What's the area of a rectangle with the width of 2 and the length of 4 plus x? Okay? So that's kind of what we're doing today. And basically you're using distributive property to do so. All right, so let's go back really quickly to problem number 3. And what they're basically saying is it's like this is the length and this is the width. And of course, since they're right next to each other, they're asking us to multiply them. So basically that's kind of what we're doing. And if you take a look at that, that should look familiar. This was just like the other day. This is where we're going to use distributive property. Okay? So I'm going to walk you through these steps really quickly here. So we'll call this step 1. Okay, step 1, and that is find the number or the integer. And this is going to be the case in 7th grade. It will get larger as you get older, but in 7th grade, one of them is going to be a number like that or an integer. Take whichever integer is alone, and thank you those of you that grabbed your pencil right now and are writing this down. And you are going to place that along the width of this rectangle, or basically to the left of this long rectangle that's split down the middle. Okay, now, step 2. Before we do anything with the length, here's what I'd like you to do. I want you to circle the two what are called terms in here. Okay, basically they're like numbers or variables. So let's start with the easier one, the 7, and we're going to circle it with the negative sign in front of it, like we've always done. There's our integer that has a value of a -7, subtraction of 7. And then the other part of course, that we're going to circle is the 5x. Now, step 3 is take this, because this is representing the length of the rectangle, and I'm actually going to write that right above the rectangle. Now, what I'm going to do is I'm going to strategically separate my two terms, or these circles, above here. So, for example, the 5x I'm going to write above that rectangle there. And what is the -7, which is going to act as a -7, is above that rectangle. So we just took our two terms and separated them above the two separate rectangles. Now, step 4, we'll call step 4, is because we're talking about length times width, and so we need to multiply them. So here's what we're going to do. To find the area of this little rectangle on the left, I'm going to multiply those two. So remember, 3 times 5x is really 3 times 5 times x. So remember, we could just multiply the 3 with the 5 to get 15. And in this case, it's just 15 times x, or 15x. Then I'm going to do the same thing with this second box. So we have 3 times a -7, which gives me, I was working ahead of myself, -21. All right, 3 times 7 is 21, and they're different signs, so it's -21. Now, when you're using the area model for today, here's what I'd like you to do. Step 5 is you're actually going to take what you have inside of here, and you're just going to rewrite it left to right. And what that's going to do is it's going to give you your answer without a double sign, meaning we're not going to have plus negative. It's just going to be 15x with your -21 that doubles up as a subtraction sign. So 15x minus 21. And we have our answer.
I thought it'd be harder than that because there are only like 6 questions.
Okay. Steps. Questions on steps. Questions on steps. We're okay? I'm about to give you guys one to try. Okay, here's the one I want you guys to try then. I want you to try out problem number 2. Problem number 2. All right? Try that out. Problem number 2. Go. All right, anyone need more time? Okay, give you guys about another 15-20 seconds there. Those of you who are finished, you can, of course, continue trying some other problems there. Okay. Now, in just a bit, right after you guys share with your neighbor, I'm going to go ahead and I'm going to pull, of course, seat numbers and ask you guys for some answers. So what I want you to do is to be prepared when I do that. So listen carefully. When you can start by when you share with your neighbor, share your answer. Okay. However, what I want you to do is share with your neighbor, and please make sure that, because I'm going to be asking for the numbers that are the terms that are put on the left of the rectangle as well as above both of these top rectangles. Okay, so whenever I pull a stick, I'm going to be asking for that. So share your answer with your neighbor, but also share those individual parts as well. Okay, all right, 30 seconds. Go ahead and turn to your neighbor and share. Go. All right. All right. Thank you, those of you that stayed on task and were helping others. Heard a lot of good talks out there. All right, good discussion. So here we go. We have 4 times and then the difference of x minus 5. So here we go. The very first thing I want to know is I'm just going to want this. What do I put to the left of the boxes? All right, the left of the rectangles. What do I put? All right. See, 33 is not in this class. All right, see 24. 4? All right, agree, disagree. What do you guys think? Okay, all right, a majority of you agree, and yes, you have that number, right? That was step 1. Take the number that's by itself, no matter if it's on the right or the left side, and place it in the front. All right, so next one is I want to know, the next person I pull, I want to know what do you put above this one and what did you put above this rectangle. All right, here we go. Seat 21 is not here. All right, seat 16.
X and 5.
X here, and what goes here?
5.
All right, agree, disagree with that. Okay, some agreements. Okay, a lot of disagreements. All right, and that's okay. Anyone want to share what they had differently there? -5. All right, agree, disagree with that. What do you guys think? There we go. All the thumbs went up. All right. Yes, guys, make sure, and this is, I spoke with a couple of you guys when we were correcting last night's homework. Make sure, guys, identify those numbers or those terms inside. That helps you, of course, not to, and that negative is crucial because it will, if you don't put it, a lot of times it'll give you the wrong answer in the end. So X up there, then -5 moves there. All right. Any questions about that part? All right. All right, final answer. What did we get for a final answer? Seat number 30. 4x minus 20. Agree, disagree? What do you guys think there? All right, well, see almost all of you guys agreeing. Let's check it out. We have 4 times x, which is just 4 times x, right, or 4x. We have 4 times -5, which gives us 4 times 5 is 20. But yes, it's positive and a negative, so it's -20. So when I rewrite it, 4x minus 20. Well done. Okay. So, any questions on number 2? Okay, I want to point one other thing out. And this is something that we've talked about, never like as a lesson, but I've just talked about here and there, and little skills within lessons or within warm-ups, our PODs. I want to take really quickly a look at number 5. Now remember, step 1 is, as we talked about it in number 3 and problem number 2, and that was you find the number that's by itself and you place it in front or to the left of the rectangles. Okay? Find the integer that is basically that represents the width and put it to the left. Now, let me ask you for number 5. Can anybody tell me what is or which is the integer that we place to the left? Okay, it's a little challenge problem. It kind of goes with something that we've talked about in the past here and there. Want to take a shot? What do you think?
The negative.
Which line thingy? That line thingy there?
Yeah.
What's that line thingy called? What's that line thingy called, guys?
Negative sign.
Negative sign. Now let me ask you, because I think you're on, not about the line thingy, but about the negative, right? You're on the right track though. You're partially right, but it's not all the way right, because a negative is not an integer, right? I'm talking about for right now we're placing an integer up front. Okay. Anyone else? Okay. Let's see if you guys remember. Actually, I think we had this on a POD just maybe last week. Let's see if you remember this. When there is a negative like this, that is the equivalent to, if you squeeze a 1 in there, that actually is represented by a -1. That's what that really is. So the answer to my question is, which integer do you put to the left? If it's a negative that stands alone, it is representing a -1 value. That's what goes as the width of our rectangle. Okay? So it's just a little side note, but it's very crucial for some of us. Because what will happen is a lot of us will do this. When we do this problem, we'll do this. We'll go, oh, I got it! Double negative! And your answer will end up being 3b minus 7, and you will get it wrong. Why? Because this -1 not only affects this first term, but it needs to be multiplied with the second term as well, which doesn't give you a -7. Okay? So that's why it's very important to realize that that negative is actually a -1. And when you distribute that -1, you need to distribute it to both, or else you're going to be like that character on our last homework, right, that didn't multiply the 3 with the 2 when we corrected our homework. That's that kind of problem. You've got to make sure that you distribute, that's the distributive property, that with that as well. Okay, let's go ahead and let's actually, we're going to kind of change gears just a little bit. All right, we're going to stick part of its distributive property still. Let's go ahead and flip the paper over to the back side. This is a little different. Okay, here's what I want to do. Okay, this actually, distributive property is within this problem, but the other day we had vocab word that, or vocab phrase that was called equivalent expressions. And we've been talking about that, even up here, equivalent expressions. So that's what kind of the main topic is. Okay, and if you take a look, it says, give 3 equivalent expressions of the following. So for example, let's take a look at problem number 2, which is actually row number 2. We're going to take this expression and we're going to write it 3 other ways, 3 different ways. But they're all going to be the same. They're all going to be equivalent expressions. I'm going to show you how to do this. Okay? So I'm going to take you step by step, but it's not really steps, as I'm just going to show you different ways to write different expressions. So here we go. This first column here, okay, which we'll just call step 1 for the sake of our lesson, is, I'll put DP, which is distributive property. Okay, I'm going to go ahead and I'm going to use distributive property with this to get an answer here. So to be able to do that, all right, I can use the area model if I want. In this case, I can also use the rainbow method because it doesn't say anything about that. So I'm going to go ahead. I'm going to circle my 2 terms inside there, the C and the +2. And like the other day's lesson, I'm going to multiply the 4 with the C, which gives me 4 times C, or 4C. And I'm going to multiply the 4 with the positive 2. So 4 times positive 2, and notice how I'm going to put positive 8. So guys, 4 times the sum of c plus 2 is an equivalent expression to 4c plus 8. They mean the same thing, just written differently. Okay? Now, step 2. For the second box here, here's what we're going to write. And this is kind of my own words on these steps, but what I'm going to do is I'm going to expand the variable. Okay? I'll put little quotes around it because it's not like formal math terms, but I'm just going to say let's expand the variable, and here's what I'm talking about. You see the 4c? Well, I'm taking you guys now back to 3rd and 4th grade. Okay? In 3rd and 4th grade, if I had something like 4 times 2, I'm sure your teacher taught you that multiplication is repeated addition. What that means is there's 4 of these added together. So 4 times 2 means 2 plus 2 plus 2 plus 2. 4 of those. That's what this is. That is really that. Okay? So, ladies and gentlemen, the 4c, or 4 times c, is no different. It is 4 of these added together. So watch. 4c is really c plus c plus c plus c. That's what 4c is. Now listen, if I wanted you to expand the numbers, 8 would really be like plus 1 plus 1 plus 1 plus 1 plus 1, 8 times, right? But I'm not going to make you do that. Instead, I'll just have you guys just keep the plus 8. We're going to only expand the variable. Repeated addition. Okay. All right. So, after this, I'm going to go ahead and write down step 3. And here's what I'm going to do here. And this is, again, it's just my own words. I'll just say I'm going to go ahead and halfway expand the variable. You say, well, Mr. Wilkins, what does that mean, Mr. Wilkins? So here's what I'm talking about. Instead of saying c plus c plus c plus c, here's what I'll do. Is I can take 2 of these c's. Instead of putting c plus c, I could put 2c plus these 2 c's. Or I can say like this. 1c plus these 3 c's. Or I can do it a different way. I could say these 3 c's plus that c. I can do it however I want. And this is where, as a person doing their homework, you can get a little creative on this last one. So in this case, here's what I'm going to do. I'm just going to kind of split it in half and say 2 c's plus the other 2 c's. And then I'm just going to put my number on the end, plus 8. And I'm okay with that. I'm okay with 3c plus 1c or 1c plus 3c plus 8. Okay, any of those would work on however you want to separate your c's on that last column there, in that last box. Okay, so this one here, this one here, this one here, this one here, they're all written in different ways, but guys, they are all equivalent expressions. When simplified, they're going to all be the same answer. Okay? They're just written in different ways. Okay? Questions on the steps?
Is there like other different ways than this?
There are a lot of different ways. There are a lot of different ways. And I'm going to have you guys for right now stick to these, but we'll talk about a few more in just a second. Okay? All right. Any other questions, guys, about the steps before I have you try one? Okay. Here's what I want you guys to try. Try out problem number 1. Try out problem number 1. All right. And I'll give you guys little extra time there, okay, because there's 4 or 3 of them, all right, total of 4 equivalent expressions. So go ahead and try out row 1 there, row 1, all right, go. Guys, if you get done early, you can go ahead and work on other ones. If you get done early, try out other ones.
Mr. Williams? Oh, yeah.
Okay. How many of you need more time? Okay. I'll give you guys about 20-30 more seconds, and then I'll have you guys share with a neighbor. Again, guys, listen, I really would like you to use this time to do the problems on your own. If you struggle, that's okay. All right, struggling means that you're getting ready to learn. All right, during the 30 seconds that I give you guys to share with your neighbors, those are the time to help each other out. Right now, you want to try to work through it yourself by looking up at our examples. That's really important. Okay, a lot of us have learned that it's not good to struggle, and that's not true. It is good to struggle. It's just, what are you going to do to try to get through the struggle? That's what's important. That's what learning's all about. Okay, now comes the 30 seconds, and I'll actually, because you guys have not 1 but 3 different answers to share with your neighbor, I'm going to give you guys a full minute to share. When you share, probably your step 1 and step 2 probably should look the same. Okay, this might be a little different, and that's okay. Listen to your neighbor when you guys share, because you might have different ones that are both actually the right answer. Okay, so make sure you guys share your whole row. All right, I'll give you guys a full minute to do that. Go. Okay, here we go. All right, so the first person, the first seed I'm going to pull, I just want you to share the first box. After you did the distributive property, what did you get? All right, here we go. All right, C17. 5a plus 15. Agree, disagree? What do you guys think there? All right, nicely done, right? 5a times 5 times 3 is 15. Okay, now the next box. All right, share with me when you expand the variable like we did here, what did you get in that box? An equivalent expression. All right, C10. Second box.
I got a plus a plus a plus a plus a plus 15.
All right, a plus a plus a plus a plus a plus 15. All right, agree, disagree? What do you guys think there? All right, nicely done, right? We have 1, 2, 3, 4, 5 A's, repeated addition, plus that extra 15. Good job, guys. All right. Now, this next one could be written a number of different ways. So I'm just going to go ahead and first ask, what do you have? If I pull your seat number, what did you write down? All right, seat 8. 3A plus 2A plus 15. Now, I'm not agreeing doesn't mean that that's what you have. Agreeing just means that you can see that that would also be the right answer. It might not match what you've got, but that's what agreeing means. Of course, if you don't think that it's the right answer, you can disagree. So agree, disagree with that one. What do you guys think? All right, nicely done. All right, so I'm going to put it out there. Anyone brave enough to go ahead and share what about another one we may have had here?
2A plus 2A plus 1A plus 15.
2A plus 2A plus 1A. That's the first time I've seen one where they expanded it 3 different times, but that actually works, right? 2, 4, 5A's plus 15. It's still 5A plus 15. Another one?
Okay, 2A plus 3A equals 5. And 15.
Equals 15?
Well,
It wouldn't be equals, but if you put it as a plus 15, that would be equivalent. Guys, look at what happened here. The difference between this one and this one is commutative property of addition. That's all it is. 3A plus 2A is the same as 2A plus 3A. All right, nicely done. Another one? 4A plus A plus 15. I like this one because it gives me an opportunity to talk about this. Some of you might go, well, Mr. Wilkins, shouldn't it be 4A plus 1A plus 15? And the truth is, ladies and gentlemen, is you actually will rarely see it as 1A. It will actually always be A. A and 1A is exactly the same thing. Now, if you wrote 4A plus 1A plus 15, that's okay as well. But 4A plus A is actually even better because that's how you guys will see it. 4A plus A plus 15. All right, nicely done. I mean, you can even, you didn't have to do this, but you could say something like 4A plus A plus 7 plus 8, right? Because 7 plus 8, when simplified, equals 15. Okay, there's a lot of different ways that you can do this. Now, I do want to share this with you guys. Let's go, there's another way I used to teach this, and this is what I'd expect from you guys if we had a fourth column, another box. But you don't have to do this, but I just want to throw this out here. Remember, this is multiplication. This means 4 of these added together. So another equivalent expression would be something like this. C plus 2 plus C plus 2 plus C plus 2 plus C plus 2. There's 4 of them. 1, 2, 3, 4. Repeated addition. C plus 2 times 4. That's just another way that all of these, every single one of these that we've talked about, at least in this row here or in this above row, are all equivalent expressions. Okay? So, any questions about that, about those columns? Okay, guys, so that lesson, right, on distributive property, area model, but also a little extra on equivalent expressions. All right?